In this video, we're going to show how to use Git and GitHub to manage a development project at the command line. Our starting point will be the terminal, where we will create an empty project directory. If you're using an IDE, such as Xcode or NetBeans, you could create a project as your starting point. What we ultimately need is a project directory, and we're also going to need at least one file in that project directory because what do we know about GitHub and empty directories?
So Git will actually not track empty directories. So we need something in there to actually tell Git to track our project directory and to actually allow us to do what we need to do.
So if you use an IDE and you create a project and you have a folder or directory for that project, you're good. If you're starting here at the command line and you're creating an empty directory, it would look like the following. We're going to make a directory here called example project. Example project has a space in it, and so I can't just type out example project. One way to do this is to put it in quotes, and that way I can have a space in there. So I've made that directory. I need to change to that directory, and I'm going to use a different technique than putting it in quotes. I can say cd, start typing example, and hit tab, and it puts a slash space after example, meaning that it will treat example project with a space in as one entity. So we're changing that to that directory. So we now have a directory for our project, and our directory has no files in it. And as was previously mentioned, that we won't be able to commit anything, we won't be able to track anything if it's empty. So we have two possibilities, and we're going to use the first one that I'm going to mention. We're going to put a .git keep file in the directory, and it's just going to be an empty file just so we have a file there. Or you could put, the starting point for your project, kind of the frame of your project could initially be there. What you shouldn't do in this initial piece of code is start developing a feature for your application. So I have an empty directory, and I can create a file in it using touch. And I'm going to say touch.getKeep.
And if you're on a Windows machine which doesn't have the touch command, you can simply create a .getKeep file using a text editor.
So now with the getKeep in place, we have a folder with a file in it. And now what we want to do is go create a repository on GitHub. So over in GitHub, I'm going to click on New Repository. And the project that we created was called Example Project. So I'm going to enter Example Project and hit Tab. And you'll notice that the repository will actually be called Example-Project because they don't allow spaces in the names, but it will still work just fine. And for the description, I will say this is an example project. It's going to be public, which means everybody has access to it on GitHub. It's going to be initialized with a README, and we're going to add a gitignore, a .gitignore file, which specifies directories and files by pattern that should not be managed by Git. And there are different gitignores for kind of different development environments. So if you're developing in C or C++, you would choose those. We develop in Swift, so we would often choose the Swift one. Sometimes you actually have to create your own, or you have to merge two of them together because you have kind of a mixed platform. But the gitignore is going to specify what things shouldn't be tracked by Git. So I'm going to say add gitignore Swift and click create repository.
And there is an ability to add a license if you would like to add a license to your repository. There's no need to actually do it, and we won't actually be doing it in this instance.
So once the repository is created, I have a .gitignore. It turns out that the gitignore for Swift is missing one entry that we like to add, and that is to ignore .dsstore files. And .dsstore files are files created by Macs, by Mac OS, that holds metadata about the items in the directory, and you generally don't want to include those in the tracking. So I'm going to click the pencil to edit this file, going down to the other section, and I'm going to put remote.dsstore in that list. And then at the bottom of the page, to save the change, I need to commit it. And you always have to provide a message when you do a commit. And the message here is going to be added.dsstore.
And what is the rules to that message, Dale?
There are a number of rules, and we do provide the documentation for what the rules broadly are, but minimally start with a capital letter. Don't put punctuation at the end. Keep it short. What's the maximum you would keep?
72 characters roughly, because there is the option to add a extended description if you ultimately need to do that.
These descriptions, though, are very important because when you go back and look at the history of your work, it is these descriptions that are going to tell you what you were doing at this point. So we could go find the place here that we added .dsstore because we made this commit message. We're going to commit this to the master branch. In the case of this repository on GitHub right now, it's the only branch we have. And so we're going to save it to that branch. So I'm going to click Commit Changes. And I'm going to go back to the repository and click on the cloner download. And we see that we have a URL that we can copy that is the HTTPS web URL for cloning this repository. So we're going to now switch back to the command line, and I'm going to do ls-al, and we see that all we have right now is this empty.getkeep file, or if you'd started with Xcode, you might have a set of files and directories for your Xcode project. This is currently not under Git control. In order to bring it under Git control, we have to do a git init inside this directory. So I'm going to say git init, and it creates an empty Git repository. And if we say ls-al, we see we have a .git directory. And if I change to that directory, you'll see the information that's in it that Git uses to manage this local repository. So the next step, now that I have a .git and I'm managing it in Git, is to add the contents that I have, which in this case is my .git keep, and if I had a project in Xcode, it would be all the files and folders in Xcode. I need to tell Git to manage them, and so I will say git add dot. And this will add all the files. We don't have a gitignore currently here, so nothing is going to be ignored. Everything is going to be added. And then I'm going to commit this with a message that says first commit. And this is committing it locally. The server right now is not being touched. We are simply kind of saving a checkpoint. We're saying at this point we want to remember what our development environment contains. So we need to be able to tell this local repository what remotes it has. And in this example, we're going to only have one remote, and it is going to be for the project. And we have this URL that we copied, this clone with HTTPS URL. And we could, in fact, use that URL in the next set of lines, but it becomes tedious to supply that URL over and over again. So Git offers the opportunity to create an alias for this URL, which they refer to as a remote. So I'm going to do the command to add a remote. So we're going to say git remote add, and then we supply the alias name, and the name we're going to use is origin. And we're using the name origin because, well, basically it's been handed to us by the Git community. The origin is the alias for the GitHub remote repository clone HTTPS URL for the project. It is the alias that is commonly used to name a project's remote repository. It is not required to be that, but the world will understand you if you call it origin.
So anytime we actually use origin in the following commands, you could actually replace it with that HTTPS URL and it would work the exact same way. But like Dale said, it is just tedious to keep doing that over and over again.
So I'm going to paste that URL, and now we've created a remote called origin with an alias of origin that we can use. So we do now have our local repository and an alias that says where the remote repository is located. Our next step is to take the files that are available in the remote repository, along with the history that's available in the remote repository. And the history is all the things that have happened. And we need to bring that down to the local and merge these things together.
Right, and we're going to be doing that with a combination of polling and rebasing. Polling simply means bring over the files and merge them in. And rebasing is saying, let's merge our histories together. So we've committed locally, and we've also committed on the remote repository, and rebasing will actually say all those remotes should be merged together. All those commits should be merged together.
And we could separately rebase and pull, or we can execute a pull command and give it a rebase option. And that's what we're going to do here. So I'm saying git, that's our command line app to run called git. Git's command that we're giving it is pull. We're saying dash dash rebase, which says merge the two histories together, the local history and the remote history. And then we're going to use the alias we created called origin to say this is where this remote is located. And then which branch we're wanting to pull from. And we only have one branch right now, and that's master. So we have pulled and we have merged the histories together.
And we can even see that, Dale. Let's do an ls. And now we notice the gitignore and the readme is now on our local machines. And if we do a git log, we'll actually now see our entire history of this repository. And we'll notice we have a first commit, we have an added DS store, and we have our initial commit, which was done both locally and on the remote repository.
So then we got a little bit of a problem. We created a gitignore over on GitHub that says certain things should be ignored. And we already have files in our project, and those files might include things that should be ignored. And when we originally did the git add dot, we added everything.
Exactly.
And one of the problematic files here on Mac OS is the .ds_store. If you moved files around sometime in this process, that would change the metadata for the directory that is holding the file, and there would be a .dsstore file. And if that .dsstore file is being tracked before the gitignore is in place, then what happens?
Then we will actually track those files, and we don't want to actually do that.
So what we're going to do in the next step is basically tell Git to not track anything.
Right.
We're going to say remove everything you've been tracking. Then we're going to tell it to track everything again, but we're going to do that at a time that we have the gitignore in place. So we're only going to be tracking the things that gitignore allows us to track. Then after we've added them, we can do a commit and push it, and then both the remote and the local are in agreement with everything, and from there we can do our development work. So let's do that. So we're going to say that we want to first remove everything from being tracked. So we're going to say git rm for remove -r cached dot.
And don't be scared of that RM. It's not actually deleting the files. It's just telling Git to forget that everything exists.
And we see it shows there rm, the things it did. If I do an ls-al, they're still there. They're just not being tracked.
And we still even have our history on Git, but we're just telling Git to forget it at this point.
So then I'm going to say git add dot, and this will add back in the things that should be tracked, removing anything or not including anything that's in gitignore. Now we need to do a commit. We need to say we want to remember where we are. So we want to say git commit with a message. And what we in fact did is we applied gitignore.
So in this instance, we didn't actually have any files that were listed in the gitignore to be removed from Git. If we had, for example, a .ds store, it would say a file to track here or something like that, deleted .ds store. But since we didn't, it says nothing to commit, working clean tree.
Another time when there may actually be something found, let's say we did create a project with an IDE, and maybe we even ran the application that was, the base application, and it created some product files that weren't meant to be tracked. That would also, we would clean up the tracking of those things here. So whether or not you have anything that needs to be removed, this is a good set of steps. Just untrack everything and then begin tracking everything with the gitignore in place. So the last step we didn't do is we committed this locally. So we have kind of this snapshot locally, but we did not tell the remote that changes have occurred. So we need to push these changes. So we're going to say git push -u origin master. And remember, origin is just the alias for the URL for the clone with HTTPS URL on GitHub. So that finished, and we are now ready to do our development work. The thing is, you should never develop on the master branch.
Right. You can always think of master as the working version of the application, and when you're actually doing new development work, sometimes it's not going to be working. So you should always do that on a feature branch.
So what we need to do is create and switch to a feature branch, do our development work, making commits and pushes along the way, and then when we're done with that development work and that feature's done, it's been tested and it works, then we're going to merge it back onto the master branch. So the next step is to actually create the feature branch we want to work on. So I'm going to enter the command git branch and then feature / and then we need to come up with a name for our feature, and I'm going to call it Hello World. Now, feature / Hello World is the whole name of the branch, but sometimes the fact that there's a slash in there is used by some IDEs, and they will put all of the things that begin with feature / in a feature folder, or all the things that are bug fixes in a bug fix folder. So this whole thing, feature / Hello World, is the name of the branch, but sometimes the pieces are used to organize the various branches. So this will create the branch, and then we need to check out the branch, and that's another way of saying we're going to switch to that branch. So git checkout feature Hello World. Now we are in that branch, and we can actually say git branch and simultaneously see that we have two branches, and that because it's green and has a star beside it, that the current branch is feature / Hello World. So we're ready to do development. We're going to do something kind of rather simple for this project. We're going to create a file called helloworld.txt. So I'm going to say nano helloworld.txt. And inside of it, I'm going to put hello world.
Right.
And normally it's hello world ! But I'm not going to put the exclamation point in right now. I'm going to think that I've properly implemented my feature, and then later realize that I haven't. We're going to do a bug fix and add the exclamation point in a bug fix phase. So I'm going to save this. And so now we have a hello world text file that is only currently known by local.
And it is only on our branch that we're currently working on. It is not on master yet.
And if I refresh GitHub and click here on the branches, we still only know on GitHub about the master branch. This bug fix branch that we're going to create isn't there yet. The feature branch isn't there yet.
Exactly.
So where are we now? We have just created a feature.
And we now need to tell Git to track it, and we need to now commit it.
So the steps for doing the committing and then pushing to the server always begin with us saying that to Git that what it should add.
Right.
Now this is an interesting thing. Even tracked files, when they're changed, need to be told, or Git needs to be told to include the files right?
Exactly. So we can check right now using what's called git status, and we can see that hello world.txt is untracked. And we've made a change. We've added that file. We need to have that in Git. So let's run the git add command.
Okay, so we're going to say git add dot.
Yes.
And then
let's run git status again. And we can see now, instead of being red, hello world is green, saying, hey, Git is actually tracking this file at the moment.
So we're now ready to commit our changes. So we're going to say git commit -m with a message describing the change, and we're going to say implemented hello world. So this is committed, but we have not pushed it yet to origin. And origin was an alias for this repository over here. So again, if I were to go refresh and then go to my example project and click here, we still only have master. If I then say git push -u origin, so that's the alias to the URL that says where this remote repository is, feature hello world.
And you're not, and previously when we ran this command, we did origin master. This time we're going to push to origin feature hello world because this is a whole separate branch. Before we were pushing to the master branch, now we're actually pushing to a feature hello world branch, and that will actually create the branch and push to it simultaneously on a remote repository.
So here it's happening. And once it's done, if I...
And you'll even notice on GitHub, there was a little yellow box saying, hey, look what was recently pushed, and we now have that branch in branches.
And we have two branches. Currently, the checkbox on GitHub is next to master, so we're currently in the master branch. I could switch to the feature hello world branch by clicking on it, and we see that the list of files up on GitHub and the list of files here are the same, except that they don't list the .git directory up on GitHub. So that, because that .git directory is for the local repository's information. So now that we have implemented our feature,
we have finished all of our development work for that feature, right?
And we want to merge this feature branch back into the master branch, because the master branch represents the working version of our application, and if we finished a feature and it works, it should be could be put in master. So the way we do this is we check out master, and then we merge what?
We merge our feature branch into master. Since we are now on master, the next command is git merge. And then we specify the branch that we want to actually merge into the current branch. Currently we are on master, so we're telling Git to merge feature hello world branch into master. Now if we do ls-al, we will now see a hello world text in our master branch, and that's exactly what we want. But we have only done this locally. Dale, how do we get this onto our remote repository?
So first I popped up master on the remote repository, and we see there is in fact not a hello world text there. And the way things get moved from the local repository up to GitHub is using push. And so we're going to say git push -u origin, which is just that URL, and then master. And now when we refresh the browser, we see hello world text is there.
So if we had done this perfectly, we would now be done. But somebody, I'm not going to point fingers, forgot an exclamation point in hello world.
So we see up on GitHub, hello world has no exclamation point. And if I do an ls-al here, more hello world, we also don't have an exclamation point. So I definitely have a bug. I would like this to be hello world exclamation point. So just like I created a feature branch, I now want to create a bug fix branch. And I'm currently in the master branch. And how can I know that? Git branch says we're in the master branch. So to create a new branch, we say git branch, and then where we said feature before, now we're going to say bug fix. And this particular bug fix is going to be on hello world, so we're going to call it the hello world branch inside of the bug fix kind of directory. But keep in mind again, this branch is actually named bugfix/hello world.
Right, and the branch should actually be very descriptive of what you're doing, because like when we do commit messages, this is how you identify what branch and what you've done on each one. So what Dale is currently actually doing, we have created our branch, now we need to switch to it, and you do that through git checkout.
And I have done that, and it says switch to branch, and just to check, we're going to say git branch. And we can see we now have the bug fix hello world branch, and it is the current branch. So now I need to make changes to my hello world. So I'm going to say nano hello world text. I'm going to put an exclamation mark at the end. I fixed my bug, save it. And I'm just going to say more hello world so we can see that change has been made. Now, Git locally doesn't know that change has been made yet.
Right, and we can even see that by doing a git status. It knows something was modified, but we still need to tell it to add it to our next commit.
So we're going to essentially do what we've done before, but we're going to be working on this bug fix branch. So I'm going to say git add dot, and the moment I do that, and say git status, we see hello world text is now included. Then I am going to do a commit of this, right?
Exactly.
And so I'm going to say git commit, and we need to supply a message with the commit, so a -m. And what we said is we fixed punctuation. Punctuation. Did I get that right?
Yep.
Now, keep in mind that we are doing a commit on this bug fix branch.
Exactly.
So we don't need to put in the commit message that we fixed hello world.txt because essentially we're in the branch that's saying we're fixing hello world.
Exactly. And if we ever wanted to go back, we could see a fixed punctuation commit, and we can actually see what files were changed.
Now, I notice we're getting this message here, which isn't causing us any problems, about name and email address. Can you explain what's going on there?
So sometimes Git loses information about you along the way. What it is asking us to do right now is simply provide our email and username that we've used with our GitHub repository and provide it on our local thing. It is telling you the commands that you need to run to actually fix that. But like Dale said, it actually doesn't cause any problems. It just might not tie your local account with your GitHub account, and that's fine.
So the next step, because where are we at now? We
have just committed.
We committed, which means it's not available on the server yet.
Exactly.
And what makes things go up to the server?
Push.
So we're going to say git push -u. And then we're going to say bug fix.
You're missing something.
I am. I'm missing where it goes. I need to push to origin.
Exactly. And again, that origin is the URL for the cloning process of example project.
And the bug fix that we're pushing we called it hello world.
Exactly.
So if I go back here, we see bug fix hello world came up here. We're in the master branch here still. I'm going to switch over. There is no bug fix branch.
Exactly, because GitHub caches things. So even if we think it's been updated, make sure you refresh the page.
And now I click, and there is my bug fix hello world. And if I click on that hello world, there's hello world exclamation point.
But we still have a problem. This fixing of the punctuation has not actually been applied to master yet. How do we go about doing that?
And before we do, let's just show it's not there. I'm going to go to master, and there's hello world, no exclamation point. So in order for the changes I made in this branch to be in master, I have to merge them. So we're going to follow the same steps as before. The first thing we're going to do is we're going to go to the master branch. So we're going to say git checkout master. Now that we're in the master branch, we're going to do the merge command and say where we want to merge from. So git merge bug fix.
And merge is spelled wrong.
Oh, yes, that would make it not work. Merge bug fix hello world, spelled correctly. And then that did the merging, but that didn't put it on the remote server. So we're going to say git push -u origin master. So we are in the master branch.
And we want to push to the remote repository's master branch.
And the remote repository is at the URL that was specified in the alias origin. So now if I refresh the page, hello world as an exclamation point in the master branch on GitHub. So the process is get your base repositories, local and remote, and get them all synchronized up and ready to go. Create a feature branch, do your work on your feature, commit, push, and then after you have your feature working, you merge it into the master branch.
And if you identify any bugs along the way, after you've already merged your feature branch into master, you should create a bug fix branch to fix them there.
And always make sure that you ultimately do merge things into master, and you make sure you push your changes locally to master, because the work that really matters at the end of the day is what is in the repository.
And make sure you commit frequently, because history helps.